Hey guys, it's time for another Phoenix video, and in this one I'm going to show you how to create a boiling water effect with Phoenix. This is what the final result is going to look like, and the effect is driven by particles. So each particle, it creates underwater pressure, which forms these air pockets, which will be our bubbles, and when they reach the liquid surface above, they create this boiling effect. So we'll start by creating a tall liquid simulator, like this. I'll just make the sides even. And I'll start by enabling initial fill up. Okay, so this way by default we have the simulator filled up up to 50% of its height. So the next thing, I'm going to add a simple particle flow system. So the particle setup is pretty simple. It's very basic. So the same things I'm going to show you here for 3ds Max, you can also do them in Maya. So let me just flip the particles so they emit upwards, and I'll make all the particles show up in the viewport. Okay, so these particles, they are going to create our bubbles. If I start the simulation right now, the particle flow particles, they are going to pass through the liquid without affecting it at all. So in order to make them interact with the liquid simulation, I'm going to pick the single particle flow event in a source, and you can see now that all the particles, they start emitting liquid as well. So I'm going to have to do a couple of changes. So the first thing is to switch the source to volume inject mode. So this is the pressure creating mode of the Phoenix source. And another thing, let me just pause the simulation right now, and there's a new thing in the Phoenix nightly. So you need a nightly at least from the 19th of October 2020. So in order to have the ability for the flip liquid sources to emit pressure without emitting additional liquid. So now in volume inject mode, these particles, they will contribute pressure underwater, but they will not emit any liquid. Okay, let me just export the grid velocity to the simulated cache files so I can preview better what's going on. So if I enable the velocity streamwise, here you can see how the particles have affected the velocities. Now they just stopped emitting. Let me start the simulation once again. And another way to visualize what's going on, it would be if I would disable the velocity streamwise, I will enable the mesh. So here you can see only the liquid surface on top, but in order to see the bubbles underwater, I can make a certain hack. So by default, the Phoenix mesh, it wraps around the places in the simulator where there is water. So if I check the invert liquid volume option, the Phoenix mesh is going to be constructed around places in the simulator where there isn't any liquid. So I will also adjust the isosurface level in order to make all the places where the particles are slightly more apart than by default, those places will be meshed like this. Okay, so we are starting to see what would become our bubbles. So let me increase the grid resolution a bit, because each of these is like a voxel wide. So I'm going to boost it to almost 2 million voxels. It's still pretty low resolution. And now you can see that because I've raised the isosurface level, we start getting these artifacts. They appear only at the beginning, then they will disappear as the simulation unfolds, and these are the places along the simulator walls where the particle density is a bit lower than usual. Okay, so now I'm starting to get these small bubbles. Let me add more pressure to the source. Okay, so the bubbles now are starting to get larger. And in order to make this more customizable, I'm going to do another change. So right here, the particle shape, by default, Phoenix uses only the particle positions, and it treats each particle as a sphere, and it treats each particle as one voxel big. So the sizes of the particles from particle flow are completely ignored by default, and in order to make this more flexible, I will switch to sphere, and I'm going to use the size of the particles. So if I start the simulation again, now the particle flow sizes are going to be read by the Phoenix source, but it turns out that these sizes are huge, so let me decrease them. Okay, so here we have the shape. It doesn't matter if it's a cube or whatever, because the Phoenix source in this mode, it reads the particles only as a sphere. I'll just set it to spheres just in order to have the same thing actually happen. And here in the source, you can also use the actual particle shape, but for this simulation, a sphere is okay. Okay. And okay, so right here the size is 10 centimeters, and I'm going to reduce this to 1.5 because I've done this before and I know this works. I'm not gonna lie to you, I've done this simulation and I've recorded it several times already, so 1.5 is good. And okay, so here some of the bubbles, they start forming, and so right here you can see that the simulation is very violent. There's a lot of these small droplets, these small air pockets actually. So in order to compensate for this, I'm going to change the dynamic settings a bit. So the first thing that I'm going to do is, for each time that you simulate water, it's good to add some surface tension, because water does have surface tension and is going to behave more realistically. And this is going to smooth out the liquid surface. It's also going to, let me just disable the invert liquid volume option right here, so you can see how the liquid surface on tops look like. So here, as the particles start bursting out of the surface, they create these bubbles on top. So this is a setup that you can use not only for boiling water, but for example, you can change the simulation settings and make the liquid a lot thicker and viscous. So you'd get a different kind of boiling effect. It's going to be like lava boiling, and or some magical pot with a certain substance. So this setup would easily translate into that as well. So by adding more surface tension, I'm going to smooth out these because they're quite ragged. Also, another thing that I want to do is to reduce the velocity of the particles. So now they're flying out way too high, so I'm going to reduce this a bit. Actually, I'm going to reduce this a lot, from 300 centimeters to 100. And again, in order to get smoother underwater bubbles, let me just enable the hack again in order to see the bubbles underwater. So I'm going to increase the number of steps or frame to 2. So this is going to slow down the simulation somewhat, but this way both the underwater bubbles and the liquid surface on top, they're going to be smoother. So later in this video I'm going to raise the steps or frame even more, but it's good to keep them as low as possible when iterating. So right now I'll go with 2. And one more change that I want to do to the particle flow setup is to add some variation to the shapes, so that not all the bubbles are equal. So I will enable the scale and add variation of 80. So because if I add variation of 100, this means that some of the particles, they will actually be zero sized, and I want all of the particles to actually contribute. So now you can see that we're starting to get some more interesting shape and more variation, more diversity. And let me just leave the simulation to run for a bit. Let's check how the liquid surface above looks. Okay, and now you can see that some of the larger bubbles, they are bursting. This is still quite turbulent, quite noisy, so we can keep increasing the number of steps per frame in order to smooth this out. So let me just, while the simulation is running, let me just enable uh, the V-Ray renderer. Of course, we're going to use V-Ray for this video. And let me just set up some render settings. So I want to add a V-Ray material. Here we have a handy preset, so I'm going to just go with the water preset. But what's specific about the water preset is just that the reflection and refraction, they are set to very bright values, and the index of refraction is 1.33, so this is the IR of water. So now the viewport mesh, it becomes completely transparent, so I'm going to change to clay mode in order to be able to see what's actually going on. Okay, I'll stop the simulation. I'll add V-Ray sun and sky. I'm just going to reduce its intensity, and let's see a render of what we have so far. So first thing that I will notice is that I need to turn off rendering of particle flow. I will also reduce the render resolution because I just want to do some test renders right now. I don't need this high resolution. I also turn off GI. And let me make these particles not renderable. Okay, so at this frame we should have some interesting bubbles underwater. Okay, and here we see that stuff is happening, so we are getting there. Let me just move it even further so that we can see what's going on at the top of the liquid surface. Okay, so until now we were using the fuel up for motion, the fuel up for ocean mode of the initial fill up. So in order to have this in any other scene where you don't have a rectangular simulator, I will disable this, and instead I will add some geometry that would actually contain the liquid simulation. So I will add a cylinder, move it up a bit so that it doesn't coincide with the bottom of the grid, and I'll make it not renderable. I'll display it as a box so I can see what's going on inside, and then I will pick this cylinder as a confined geometry for the simulator. Okay, so if I start the simulator right now the liquid is created only inside the cylinder. So in ocean mode, we had these pressures supporting the liquid from the sides and from the bottom. But when we have a confined geometry like this inside of a certain shape, these pressures, then they don't work anymore. I've disabled fuel for ocean, so the liquid would subside somewhat, and after a few frames it's going to bounce back up, and eventually it's going to settle at a certain level. So you can see right here that I have my container dimensions exaggerated a lot in order for this effect to be less prominent. And in order to counter this effect, you can do two things. So you can increase the scene scale, or you can make your container larger than it's actually realistic, and you can increase the steps per frame, which is the realistic way to compensate for the liquid losing volume. So right now I'm using 2 steps per frame, but let me just increase them to 8. So this is going to be our final number of steps per frame. For this simulation now it's going to take longer to simulate, so you can see that each frame is going to take like 6 to 8, maybe 9 seconds on my machine. Okay, and so once I've done this, let me just also do a few things that always need to happen when you have liquid rendering inside a certain container, for example in a glass. So if I render the liquid right now, you can see that there are some edgy artifacts at the borders. I'm going to actually cut these out by using a render cutter. And in order to have this happen smoothly, I'm also going to switch from mesh render mode into, I'm just in the preview, from mesh render mode to isosurface. So the mesh render mode, when you use a cutter, it just simply removes certain voxels, but it doesn't cut it cleanly and smoothly. But instead, in isosurface level, during rendering, you get a completely smooth cut of the liquid volume. So let me just duplicate this cylinder. Okay, so I'll make this renderable, but I need to make it non-solid, otherwise it's going to obstruct the Phoenix simulation, and probably it already did because it was running. Okay, so again I'm going to restart the simulation. I'm going to display this as a box. So cylinder, the cylinder 0.002 is going to be our actually the visible, the renderable glass container that is going to contain the liquid. So I'm going to show it, and I'm going to shrink it. And increase the outer shell amount. So I want to do this in order for the container to actually penetrate inside of the liquid mesh and be able to cut it cleanly. So now if I pick the second container as a cutter geometry, by default cutter geometry just renders only the stuff inside of this volume. But since I want to just remove these artifacts and actually get all the rest of the thing rendered, I'm going to use invert cutter. Okay, so it's going to cut out all the air pockets and inconsistencies on the border of the simulation. So if I render this, whoops, okay, so now I'm going to assign a second V-Ray material to our glass geometry, and again I'm going to use a preset. Okay, and here it is. Now we have liquid inside the glass, and it renders fine. So the liquid penetrates a bit into the glass, and so we have proper reflection and refraction. And we see how our bubbles are forming. So this is going to be the render setup for this simulation. Okay, so now that I have my confined geometry for the simulation, I can no longer use the invert liquid volume hack. So the isosurface level should stay in order to make the bubbles larger. If you reduce this value, the bubbles are going to become smaller. But I cannot use the invert liquid volume, so in order to preview what's actually going on inside the mesh, I can go back to using the velocity streamlines Let me just disable auto range, increase the lower bound, and so this way I can see the velocity trails that the particles are leaving. Okay, and I will also increase the inject power even more because I think that these bubbles are way too small. And I will restart the simulation. We'll pause the video and we'll be back. Alright, so now we are 50 frames deep into the simulation, and this is how it looks like now. And the particle fall particles, they have stopped emitting because by default particle fall emits only for the first 30 frames. Let me just go back to the particle view, and I will change the birth of the particles just to use a fixed rate. So 60 sounds good, and I'll extend this to 100 frames and start the simulation again. Alright, so the simulation is done. And again, here is how it looks. If I rewind back. So I could also increase the number of particles. Maybe I need to increase the rate of birth, but I will go with sequence render for this one, and then I'll be back again. Alright, so the render is done, and here is how it looks like. So we need more particles, but overall this is the idea. So thank you for watching, and see you next time.